Next, we're going to talk about infinite limit. When we talk about infinite limit, means the limit is like infinity or negative infinity. Those are infinite limit. Okay. Now take a look at this function, 1 over x squared. This is the graph of the function. Okay, 1 over x squared. Okay. When x approaching 0 from the left side, so it's going to go from the left side. So go along the curve. The function value is going to keep on increasing and increasing and keep on going up. Okay. So without bound. So what happened here to 1 over x squared? We say that 1 over x squared going to infinity. So we say this limit here is equal to infinity. It is positive infinity, but when it's positive infinity, you don't need to put a plus sign there. Now, what about when x approaching 0 from the right side? When x approaching 0 from the right side, remember we have to go along the curve. Again, you see that 1 over x squared is going to keep on going up, and it go to positive infinity again. So that's equal to positive infinity. The two-sided limit right here, this two-sided limit will be equal to positive infinity. Okay. Now, because infinity is not a real number, this is just a special case of does not exist. Remember, when the limit exists, the limit has to be a real number. So infinity is not a real number. So that is a special case of does not exist. Now I'm going to make a remark here to clear some of the confusion. So limit does not exist, we say D and E, can include different cases. You could have left-hand limit does not equal the right-hand limit, then the limit does not exist. Or the left-hand limit does not exist, or just the right-hand limit does not exist. If one of them does not exist, then the two-side limit will not exist. For the two-side limit exists, both of them have to exist as a real number. Okay. Now another case that the limit does not exist is when the limit is equal to infinity or negative infinity. Because infinity and negative infinity is not a real number, so the limit does not exist as a real number. Okay. For the limit exists, it has to exist as a real number. Okay. Now, when the limit is equal to infinity or negative infinity, we call those infinite limit. Okay. Next one, this is a graph or a certain function. Okay. What happened when x approaching a from both sides? Well, we see the function keep on going down. Okay? So the limit over here, we will say it is negative infinity. Remember, this is also a special case of does not exist. Now, we have this definition right here. This is the definition for vertical asymptote. This vertical line x equal to a is a vertical asymptote if at least one of the following is true. So either the left-hand limit go to infinity or negative infinity, or the right-hand limit go to infinity or negative infinity. One-sided limit here is equal to infinity or negative infinity. Then we say this vertical line x equal to a, it is a vertical asymptote. So sometimes we abbreviate this vertical asymptote as VA. Now take a look at this example right here. We're trying to find the limit of this function as x approaching to 3 from the right side. Now what happened for the numerator? When x approaching to 3, the numerator is going to approaching to 2 times 3, which is 6. What about the denominator? The denominator is going to approach to 0. Now because x approaching to 3 from the right side, x is greater than 3. So x minus 3 is greater than 0. So the denominator is approaching to 0, but from the positive side right here. Now, what happened when the numerator goes to 6 and when the denominator goes to 0 from the positive side? Now, we know that positive divided by positive is positive, so the result will be positive. So think about when you pick those numbers closer and closer to 0, but it stay positive. Say the first one I pick here may be 0.001. 6 divided by this is 6,000. And then you pick the number here even closer to 0, say 0.00001. Dividing here, you have 6 followed by 50 right here. Now, as you pick this x here closer to 0, what happened to this quotient? This quotient is getting larger and larger and it go to infinity. So we say this limit over here is equal to, notice that when you have a quotient like this, the numerator go to a fixed positive number and the denominator go to 0 but stay positive. Then positive divided by positive will be positive. So this is going to go to positive infinity. Okay? Now what happens when the denominator here goes to 0 from stay negative? We'll say the numerator go to 6, but the denominator go to 0, but it stay negative. So you just put a negative sign here and over here. So the result here will be negative. So that will go to negative infinity. That will go to negative infinity. Okay, this next one here. We're trying to find this limit. Now, x times cosecant of x. We know that cosecant is a reciprocal of sine. So we can rewrite this function as x over sine of x. Now, what happened to the numerator? The numerator is going to go to 2 pi. X is approaching to 2 pi. What about sine of x? Well, this is sine of x from 0 to 2 pi. X is approaching to 2 pi from the left side. And you see if we go along the curve, sine x is going to approach to 0, but it's going to be below this x-axis. So the function value is going to stay negative. So sine x is going to approach into 0, but it stay negative. So numerator go to 2 pi, denominator go to 0, but stay negative. Positive divided by negative is negative. Therefore, this goes to negative infinity. And just like this case right here. Okay, the next example, the limit of this function. Now, if you substitute 1 into x, then 2 minus 1 will be equal to 1. The numerator is going to go to 1. What about the denominator? The denominator, if you plug in 1 here, that will go to 0. Now, because of the square over here, the result here is going to be positive. When x approaching 1, the result here will be positive. Okay, so positive divided by positive is positive. That will go to positive infinity. So we have an infinite limit, which is infinity for this. Okay, now take a look at this example. When x approaching to 5 from the right side, what happened to this function right here? You see the numerator is going to approaching to e to the 5th power. The denominator is going to go to 0. But because x is approaching 5 from the right side, x is greater than 5. So x minus 5 will be greater than 0. So it's going to stay positive. Okay, so the denominator approaching 0 from the positive side. Positive divided by positive is positive. So that will go to positive infinity. The last part over here, as you recall that the function tangent of x period equal to pi. So it's going to repeat every pi. So from negative pi over 2 to pi over 2, the graph is going to like this. So you can think about the function dance. So it's going to look like this. And then it's going to repeat. It's going to repeat every pi. Okay. So what's the limit of this function tangent of x as x approaching to pi over 2 from the left side? So here's pi over 2. So we're going to go along the curve and x approaching pi over 2 from the left side. Now you see the graph is going to keep on going up, keep on increasing. So the limit is infinity. So the infinite limit is infinity. Now remember, if you have a one-sided limit equal to infinity or negative infinity, then this vertical line here is a vertical asymptote. So x equal to pi over 2 is a vertical asymptote, VA. Similarly, what happened to this function as x approaching to negative power 2 from the right side. So here's negative power 2. And let's go along the curve on the right side of this. Now you see the function value keep on decreasing, keep on going down. So the function will have infinite limit to be negative infinity. So this limit here is negative infinity. And we'll say that x equal to negative power 2 is a vertical asymptote. So this is a vertical asymptote because you have this one side limit equal to negative infinity. Now, what are the asymptote for this function y equal tangent x? You have this, and this, and you actually keep on repeating every pi. So if you want to write down all the asymptote for tangent of x, then you will put down x equal power 2 plus k pi, because if you add any multiple pi, you get another vertical asymptote. So k over here are integer, okay? So k will be 0, plus or minus 1, plus or minus 2, etc. Those are called integers. Okay, the next one. The graph of y equal to ln of x, okay, how does the graph look like? So if you think about the function dance, it's actually like this. Okay. The function is going to be like this. The graph of that is going to be like this. Okay. Passing this x-intercept 1 right here. Okay. And over here, it was going to going down, keep on going down. Okay. So what happened when x approaching to 0 from the right side? So let's go along the curve and take the x closer and closer to 0 on the right side of 0. The function keep on going, the graph is going to keep on going down without boundary. So ln of x is going to negative infinity. So this function will have an infinite limit to be negative infinity when x approaching 0 from the right side. So that is negative infinity. And we'll say that this vertical line over here, is vertical asymptote for this function because we have this one-sided limit, which is an infinite limit. Okay. Now the last one, I want to give you some help on this homework problem. In the homework, you see this problem. We try to find this right-hand limit. So how do you? First, we can factor this numerator and denominator by trying error. Okay. Now, when x approaching to 2, if you plug in 2 over here to the x, you see the numerator is approaching to negative 8. Just plug in. Okay. What about the denominator? Now, the denominator, when x approaching to 2 from the right side, which means x are greater than 2. The right side of 2 are greater than 2. Those numbers are greater than 2. So x minus 2 will be positive. So we know x minus 2 is going to go to 0, but it's going to stay positive because x minus 2 is greater than 0. What about x minus 3? If we substitute x to be 2 in here, 2 minus 3 will be negative 1. So negative times positive is negative. So 0 times negative 1 is 0. So this is going to go to 0. The denominator is going to go to 0, but it's going to stay negative. Now, negative divided by negative is positive. So that is going to go to positive infinity. Negative divided by negative is positive, and this is a fixed number, and this goes to 0. So that is going to go to positive infinity. So that's the end of our lesson 2. Okay, that's the end of section 2.2 also.